These pupils from Swinton School in South Yorkshire are building solar buggies they've designed themselves. It's part of a cross-curricular project designed to draw out the maths, design and technology and science elements of engineering. On hand are the teachers from each department. They are Terry Dawson, maths teacher.
The energy of the students when they pick up the kits and get into it and start to learn is fantastic.
From design and technology, Steve Barnett.
This is just throwing them in at the deep end, really.
And from the science department of a nearby school, already using the solar buggy project, Chris Williams.
I think it's going really well. Children seem to be really well engaged.
Also on hand is David Golofsky, designer of the solar buggy.
Young engineers, that's what this is for. And young people who can think. They want to be challenged to think.
The project starts with a collapsed timetable day for the pupils to engineer their buggies. The day is split into 3 key sections.
Initially, we're looking at students being able to take instructions and assemble the basic design car, so they're learning and thinking for themselves and working together to actually put the car together. After that, we're going to provide them with some more equipment that they will then have their choice of using, hopefully from exploring their design to improve and refine their original design, and then we're going to go for a race at the end to see. Following that up, we're going to look at some of the mathematics involved in designing cars and around solar energy, so that the students can actually appreciate how everything comes together.
But first, with the class split into pairs, it's about teamwork, understanding instructions and following them with very little input from teachers.
The initial stage of the project is about getting students to work on a task from a set of instructions, and so we give the students the project to do, we give them the instructions, and it's up to them to actually work away and do that task and build the prototype design.
And assembly seems to be going well.
It's a very basic kit to start with, which actually fits together very quickly to give you the bare bones of a design of a car that runs. And then students can look at the suspension system, problems that they're having with the axles, how they can cure that.
The new curriculum demands problem solving and personal learning skills. The cross-curricular approach encourages this. But it also allows pupils to see real-world applications of subjects, all within an engineering context, serving to emphasise the fundamental importance of both maths and science in engineering. The pupils become electrical engineers when dealing with the photovoltaic cells and mechanical engineers when adapting the gearing.
They like building the buggy and racing them to start off with. They don't necessarily see where all the engineering aspects are coming from, but when it's actually pointed out to them, oh well, you've just used some electrical engineering when they're looking at the voltage and how they would improve that, then they see the wide-ranging implications.
To connect the leads from the motor to the solar cell, it's got these little clips, and you need to squeeze those hard together.
Once the basic buggy model is built, there's plenty of room for improvement. It's here that the engineering begins.
The kids, through their problem solving, through trial and improvement, they improve on the car and make it work better. And at each stage it keeps building up their self-confidence, which is important.
You get a chance to see how your car actually runs, and then you can see.
The simplicity of the buggies allows pupils to customise them, refine their designs and improve performance. With a race at the end of the session, each team are looking for straight-line speed.
You've noticed when you've actually tried your car out that now it's tending to veer off. Why do you think that's going to be?
Well, it's pointing the wrong way at the moment, but at first it was going to the right, so we moved it a bit to the opposite direction.
They're finding out problems that they're solving themselves, and that was the part of the exercise really, is that we want them to develop problem-solving skills, we want them to be able to analyse a problem and have a look at it and experiment really with the kids.
You've had the opportunity now to go outside and test your initial designs.
Once all pupils have had a chance to build and test, there's an opportunity to share problems and solutions.
We had a problem with the 3-to-1 gear where some of the cogs kept falling off, so we needed to adjust them a bit so that they all fitted together and worked.
First our wheels were like 27:1 and it were really stiff, so it wouldn't turn at all, but we changed it to 3:1 and it goes really fast downhill, but on the way up it doesn't go as quick. So
next, with extra materials such as chip trays, tinfoil and CDs, pupils can modify the cars, taking on the role of design engineers.
We made it look like a car by putting sides on it, but we couldn't put a roof on it, otherwise it blocks sunlight getting to the solar panel.
So because we put these like side bits on, we put foil on to reflect light onto it, so it like makes it easier for solar panels to get light. And then that's front just for decoration.
We put foil on this bit so that when the sun reflects on it, it'll reflect onto the solar panel.
It's fastest like on flat and not uphill, so we're hoping we don't have to go uphill.
And then we put this armour on it to make it more streamlined so it might go faster.
When the students decide to change the designs of the buggy, what we tend to find is that they come up with some weird and wonderful designs. So they might, after they said, oh well, we'll redesign this, we'll put spoilers on and things like that, and then they're looking at, well, does that add weight to the design of the buggy? Will that slow the buggy down? What about the friction? And so they tend to start taking things off before they start adding things.
We wanted to put more features on it, but it'd make it heavier.
Too heavy and it wouldn't have moved as fast as what we would have liked it to move. So we had to have like little light things on to make it so it'd still move as fast, but so it'd look good as well.
They've worked out some quite innovative changes to the designs. The next phase really is to take them outside and see how well they perform.
But the pupils are discovering that alongside the need for understanding the theory behind the buggies, good build quality is essential.
I think it's important that students realise that although some people will go on and graduate and become engineers, there's a whole host of other careers within there for students that may not graduate but want to be involved in engineering.
We find that the engineering technician side of the work is as important as the science theory, the maths theory and the design planning. And putting the buggy together is really important, and if you put it together in a format that is that won't work, well, the whole buggy's failed.
Finally, when the cars are all tuned to perfection, it's time for the race.
Take your marks, set, go!
No records are going to be broken, and in fact, it's difficult to determine a winner. Straight line speed is not much in evidence, but the pupils and teachers are enjoying it. After the race, it's time to analyse the science.
So we're going to do 3 separate bits of maths. One about finding the centre of a wheel using maths. We're going to look at maths to actually measure the speed that we're travelling to see whether it's about taking some of the subject knowledge out of that particular project and looking at how that develops a little bit more. So the maths that we've actually done in there, we can then say, this is one of the reasons why you need maths, science, whichever subject we're looking for, as part of a team solving a problem. What I'd like you to do then, I would like you to, just by using your eye, have a look and see if you can find the centre of those 3 circles.
There's plenty of maths to explore, such as circle trigonometry and gear ratios. Science can look more closely at solar cells and power sources. Further research is encouraged by directing pupils to the World Solar Challenge website and the British competition entry from Durham University.
We're also going to have a look at the World Solar Challenge, the real one for last year, and we're going to have a look at working out what sort of speeds Mr. Barnett would need from his solar-powered person-carrying car to be able to win next year's competition.
As a follow-on to the day, further time is allowed across maths, science and design and technology to allow pupils to do further research and to enhance their designs and understanding of the subjects. Their research can then be developed into PowerPoint presentations or posters.
What we tend to do is to leave it to the students' own ownership. Otherwise they will think, oh, well, it's sir or it's miss teaching us. Whereas if we give the ownership to them, well, they've got to find out why you'd use the solar energy, so they have to research that. So we'd actually put the onus on the students to find out, and it's the quality of the presentation at the end of that we'd actually find out whether they had fully understood more of the information.
These follow-on projects give opportunities for subjects other than maths, design and technology, and science to get involved too.
I see no reason why we couldn't get English involved, perhaps in terms of selling your solar-powered buggy after and creating an advertising campaign for it. The students could present some of the work that they'd actually done using PowerPoint, so ICT could be involved in it. You could look at the design aspects and which designs would sell better, and then you can get art and design involved in it. The possibilities are endless, really.
And although it might seem that a project like this is just fighting for space in an already crowded timetable, the day reveals ways of using time more effectively.
One of the criticisms of using an approach like this is the time that's involved in it. And yet today we found out, just by doing that project on centering a circle, that idea of making perpendicular bisectors, we use in maths, it's part of our maths examination, and we would use it in a maths question context in an exam. And yet working with Steve today, he said we'd do that in engineering drawing just the same. So that's two separate subjects teaching the same basic skill.
For Terry Dawson and Swinton School, today was just a taster. Doing it again, Terry would make the project bigger, include more pupils, and extend the time spent on it.
Today was a very condensed version of where we could go. We could look at different forms of construction and look at different ideas of where we'd use mathematical construction. We could look at different properties of shapes. The idea of the off-centred wheel could lead us all into different paths that objects can take, like cams and cam followers, which leads us into loci in mathematics.
This cross-curricular approach has a number of benefits, not least how it fits into the new curriculum.
At the moment there's a whole raft of changes that are coming through about learning in context and about cross-curricular work. We've got a new national curriculum that's rolling out with the personal learning and thinking skills, but within each subject there are separate process skills. They're now getting much more interested in not just learning facts but learning skills as well.
The new diploma has an ideal entry really for using this sort of project. You can develop this even further for the diploma and get certainly the credits that will build up going towards the engineering diploma, and you could use it for the science diploma as well.
A project like this can only be a success with people behind it. Getting support from teachers across a number of disciplines is essential, as is the backing of the school. But once the project is up and running, more and more people want to be involved.
Get a great enthusiasm from the pupils, which does have a knock-on effect for the staff. All the staff want to be involved, and in timetabling what we're trying to do is to share out the days when we are doing the activity, so it tends to have a snowball effect.
And for the pupils, with enthusiasm and engagement through solving problems themselves, comes learning.
I want learning to be fun. I want students to have fun whilst they're learning things, and this is the sort of project that does that.
Come on, open your push, yeah!